The Space Shuttle program was the fourth human spaceflight program carried out by NASA, beginning in 1972 and ending in 2011. The shuttle program was unique because the shuttle is the only reusable manned space vehicle to make multiple flights into orbit. The Soviets had a shuttle called Buran that was very similar, but only flew one unmanned mission before it was cancelled. It was important that the shuttle be reusable because it solved the issue of cost, allowing it to be used as an orbiting science lab, launch satellites, fly missions for the military, and carry teams of engineers to repair things like the Hubble Space Telescope and the International Space Station. Unlike its predecessors, such as the Apollo spacecrafts, who returned to Earth's surface by being thrown into the ocean and fished out by divers, the shuttle was born out of NASA's revolutionary new design, to have a spacecraft ascend like a normal rocket, but land like a plane. Its design has three main parts. The first is the orbiter, the part that looks like a plane. Next is the external tank, which is the big orange part, and two solid rocket boosters on either side of the external tank. When the shuttle lifts off, the external tank and solid rocket boosters' hydrogen-oxygen fuel mixture produces 375,000 pounds of sea level thrust. After 2 minutes, the solid rocket boosters drop off into the ocean to be fetched and repaired for another mission. The external tank continues to run until it burns up all of its fuel, at which point it drops off from the orbiter as well, though this one burns up in the atmosphere on the way down and therefore won't be reused in future missions. When it lands, it does so like a glider, landing on a runway and using a parachute to slow itself down. But like any innovation, it had to be tested. Testing began with the Space Shuttle Enterprise. The Enterprise, originally planned to be named Constitution and unveiled on Constitution Day 1976, was named so after hundreds of thousands of Star Trek fans wrote the President requesting it be named after the famous starship. Despite the name change, the Enterprise never made it into space. In fact, it was never meant to fly in the first place. It had no propulsion system, and being a prototype, was built without a lot of the vital parts like engines, radar systems, or a heat shield. Its series of flight tests, called the approach and landing tests, were split into 3 phases. During the first, called Captive Inert, it remained unpowered and uncrewed atop a modified Boeing 747 that served as its shuttle carrier aircraft. In Captive Active tests, it was powered by fuel cells and crewed, but remained mated to the SCA. Finally, in the free flight phases, it was carried by the SCA to launch altitudes, where it was jettisoned by explosive bolts and glided down to a landing on the runways. After the Enterprise's last free flight in October of 1977 came the Shuttle Columbia, the first space-rated orbiter in the shuttle fleet. The Columbia was much different than the Enterprise. Its aft fuselage was constructed differently, and it had added interfaces on which to mount the orbital maneuvering system pods. It had a state-of-the-art thermal protection system using things like reinforced carbon-carbon on the leading edges of the nose cap and wings, and Nomex felt blankets on the upper payload bay doors to protect the spacecraft from the extreme temperatures of space and re-entry. With the Columbia also came the addition of reaction control system thrusters and hydraulic mechanisms for the landing gear. After Columbia, NASA's original plan for a second operational orbiter was to just refit the Enterprise, but time and financial constraints instead gave way to the birth of the Challenger. The Challenger actually started as a vehicle built as a structural test article, which is a spacecraft used as a platform for testing that could be converted into a flight vehicle, but it wasn't as far along in the construction of its airframe as the Enterprise was, making it easier to refit for spaceflight in the late 70s, ending in 1978. The Challenger and all orbiters after it had fewer tiles in its thermal protection system than Columbia, though it used more of the low-temperature reusable surface insulation tiles than later orbiters, which are white tiles generally used in areas where temperatures don't exceed 1200 degrees Fahrenheit. Most of the tiles were replaced with Nomex felt insulation, making it lighter and able to carry 2,500 pounds more than Columbia. The Challenger was also the first orbiter to have a heads-up display system, allowing data to be presented to crew members without requiring them to look away and refocus their eyes. Finally, the Challenger was the first shuttle with Phase 1 main engines, beginning in its 6th mission, giving it a longer service life and greater thrust. Following the Challenger was the Discovery in 1983, which boasted many improvements in weight. Instead of the white LRS side tiles on the fuselage, the Discovery favored quilted, advanced, flexible, reusable surface insulation blankets. It also used graphite epoxy instead of aluminum for the payload bay doors. Next came the Atlantis in 1985, which was very similar in structure to the previous orbiters. One thing that makes it stand out, however, is that it was the latest shuttle in the fleet at 151,315 pounds. Lastly came the Endeavour, which included lots of improved hardware designs, like a drag chute that cut the shuttle's rollout distance in half, an updated avionics system with advanced general-purpose computers, and an improved version of the auxiliary power units that provided power for the hydraulic systems. Many of the improvements made during the progression of the Space Shuttle program helped NASA get to where it is today. Even everyday things like smoke detectors, which were first developed on America's first space station, Skylab, which was boosted into orbit by Space Shuttle Columbia, came about due to the wonders of the Space Shuttle program, arguably making the shuttle one of the most influential innovations in our nation's history.